So first, I want to introduce the goals for ROS2. You've probably seen them last year at ROSCon. It's basically the same slide. There would be a platform image at the bottom you don't see. But there are things in ROS1 which are not working as good as they can, and there are scenarios which are not addressed well enough. And these are things we want to solve in ROS2 to make these use cases better. And the first one is clearly a scenario with multiple robots. When you have unreliable networks involved, ROS1 doesn't perform very well. Another thing, when you develop a prototype, ROS1 is great, but as soon as you want to deploy it in a product, you might hesitate if it really performs that well when it's at a customer side. So you maybe throw out ROS1 at that point. The next one is a microcontroller. We already heard from Morgan how much pain it is to actually run ROS1 or try to embed it in a small microcontroller, and how the ROS2 will address that. Another case, we'll hear another presentation later, is real-time, which is also something ROS1 is not that good at and usually delegates to other toolkits. And the fifth one, which you also don't see on that slide, is platform support. Linux is obviously our tier 1 platform. It's well supported. OS X, you can build it from source. It works pretty decent. But if you try it on Windows, you're pretty much in the rain. It's like, it's not well supported. You can do it if you have a very high pain tolerance, but it's not supported from us. So this is things we want to address in ROS2 like from the beginning. So all the rest of the talks will basically be demos where you see certain parts which we already have working, plus some technical background how they work. And all of those work currently on all 3 platforms. So we can build the prototype on Linux, OS X, Windows, and they actually work on those. If you happen to want more details about the demos or run the tutorials yourself, you can do them. They are on GitHub, ROS2/ROS2. There's a wiki. You'll find a lot of information. And we will give you more information than is written down in there. So I'll start with a very simple demo first, a publish subscribe demo. Just a second. Go on a full screen. So on the left side, you see the first shell running a publisher, very spectacular, publishing Hello World. And on the second side, if I get my cursor over, we'll see a listener. It gets the message Hello World. Okay, that's not that spectacular. But actually it is. So we've seen these 2 processes. The first thing you hopefully noticed, there was no third window running a ROS core. Because since ROS2 works on top of DDS in this case, it doesn't need a central master. It works completely distributed. And the talk itself uses similar to ROS-CUP, a C++ client library, which then uses a middleware interface. And under this interface, we can implement the interface with different vendors. Because DDS is a specification, there are multiple vendors providing that. So there's Connex on one side and OpenSplice on the other. And actually what we saw in the demo was the talker was using OpenSplice, which was selected at link time of the executable, and the listener was using Connext. And since both of those vendors implement the DDS protocol according to the interoperability standard, they actually can talk to each other, even if they're different vendors. A short look to the source code, that's a ROS1 code. So you have a callback, which gets called when you receive a message, and the main function which initializes the code and creates a subscriber and then spins. We'll keep the code in comments here. How does that code look for ROS2? So the first thing you will probably notice is we use like C++ stuff. So for example, auto to keep like the line short, otherwise it wouldn't fit on the slide. You have the callback signature, which is not obvious from the type def, but it's not using boost anymore. It's using STD shared pointers, because we have that in STD now, so we don't have to use an external library for that. The callback here is still a normal function, but since it's C++11, we could easily use a lambda for that. But there are other differences between ROS1 and ROS2. For example, the node name you pass in. It doesn't get passed into the init function, to the global one before. But now it gets passed to the node because it makes more sense. It's the name of the node. So that allows you, for example, to create a second node with a different name within the same process, something which is not possible in ROS1 either. Another difference is when you create a subscriber, you pass arguments like the topic and also some QoS profile. We hear more about that later. But this function is templated on the actual message type. In ROS1, that was not the case. So you can sometimes fool ROS CVP and create a subscriber for one type, and then actually letting it handle another one, which is pretty ugly. And the last one I want to mention here is the spin function. Before it was a global function relying on a signal behind the scene. It magically knew which node to deal with. And now you actually pass in the node. You can do a spin call on multiple functions, on multiple nodes, for example. Or there are also different execution models where you might not call a simple spin function, but create more complex scenarios. I also mentioned briefly the DDS vendors. Currently, we have implementations for RTI Connect, PrismTech OpenSplice, and since very recently from Eprosima, Fast RTPS. Don't confuse that with free RTPS. RTI is a commercial license. It's well supported. The government uses that in a lot of projects. We get government funding, so it's good if they can use that. There are actually two variations, a static and a dynamic runtime implementation of the types, which is more technical detail. OpenSplice is commercial and LGPL available, so especially for us as the default one, we currently use OpenSplice because of that. Twin Oaks, we started working with that, but since they only have a commercial license, we didn't continue for now. Maybe the vendor will pick it up and provide an implementation on his own. Fast RTPS is very interesting. It's a pretty new implementation. It's also LGPL. There's one feature which is still missing for messages which are bigger. So it doesn't support fragmentation yet, but they're actively working on that and try to get that resolved by the end of the year. And then I think Fast RTPS will be an interesting alternative. We already heard about free RTPS in Morgan's talk before, which is aiming more for small systems. It doesn't implement the full specification, but we're working on that. So now I hand over to William for the next demo.
Hello. My name is William. I'm also at the OSRF. So I'm going to talk a little bit about transparent inter-process communication. So for those of you who don't know what that is, basically that's where you skip the serialization and network part when publishing and subscribing. So when you're in the same process with another node, or when you're publishing and subscribing to the same topic within a single node, you can skip a lot of the work and save a lot of time and get a big performance boost. Sort of related topic that I'm not going to talk about here, but I talked about previously at previous ROSCons. The fact, and Dirk touched on, was that we're changing the API design for nodes in ROS1 when we're going to ROS2 so that you can have multiple processes in the same node, so this becomes more applicable. It was used in nodelets, but we hope that people can use it more and get a performance boost more frequently. So like I was saying, the way the inter-process publish subscribe works is that you have a publish call that gets serialized, the message you give it, and that gets into the network stack, which is picked up by the network stack on the other node, deserialized, and finally given back to your callback. We can skip both of those steps with inter-process and go directly to passing the data from the publisher to the subscriber without serializing or going to the network. You know, we often hear about what ROS2 is going to do better than ROS1 or what ROS1 does poorly at, but ROS1 does really well in a lot of cases, and this is one of them. It already has the ability to do most of this stuff. It can avoid serialization and deserializations. In the cases I mentioned, it can avoid the network stack, and it can avoid copies, allowing you to do zero copy communication between publishers and subscribers within a single process. But there are some caveats to that, one of which is, I quoted here from the documentation on the wiki, when you're doing this zero copy inter-process communication with ROS1, there's an implicit agreement that when you give it this message as a shared pointer, that you're not supposed to modify it after you call publish, because it's going to then take that shared pointer uncopied and give it to other subscribers. But if you violate that, then some really weird behavior could happen. So diving into that a little more, taking this example, you can see if the first thing we do is create a new message and put it into a shared pointer, and then we assign some information into that message, and then we call publish on it. And then after that, I do the really bad thing, which is I modify the data after giving it to publish. So I violated this contract. So the question I have is, will the subscribing callbacks to this topic get testing or testing 2? And you have to look into the implementation to figure out what happens, actually. They'll actually get testing Because what happens when you call publish, that third line in this example, it actually goes all the way through and calls the subscription callbacks directly. They don't get rescheduled into the spin function. They get called through directly. And so they are going to get testing because the line which modifies it to testing 2 doesn't happen until after those callbacks have been executed. But if they store that share pointer and then use it later, they may get the different value, and that's very surprising behavior, I think, if you didn't read the documentation and made this mistake. The other concern here is that if the subscriber callbacks that are getting called directly from your publish call are blocking or take a very long time, it can be very surprising. So you can have a situation where you have a publisher and a subscriber which work well together, and then you add a new subscriber to the mix, and suddenly your publish call is blocking, and you don't understand what's happening. It can be very confusing and hard to debug. So these are some of the things we'd like, if we're going to encourage people to try to use multiple nodes in a single process to get efficiency gains, we want to try to make it as a unsurprising experience as possible and a safe experience as possible. So we want to try to fix some of the things in ROS 2, and that's what I want to talk about today. So ROS 2, we're going to do the same things as ROS 1. We're going to avoid serialization, deserialization by shortcutting the middleware, as well as the network stack and all that. But we want to provide a safer interface to zero copy publishing and subscribing by using unique pointers, which is a new feature in C++ 11. It's been in Boost, but we don't use it in ROS 1, as far as I know. And also, we want to try to strive for more consistency between the inter-process behavior and the intra-process behavior so that you can get a better or less surprising experience when using the APIs in different ways. So, so basically, we want to try to solve this implicit contract by making it explicit instead, where you're not going to modify the data after you give it to the middleware to share with other callbacks. So we're going to do this using a unique pointer. For those of you who don't know how a unique pointer works, I've got a little example here. I create 2 unique pointers, A and B, and I allocate a new class and put it into A, but I don't put anything into B. So before the last uncommented line in that example, A is a valid pointer to a class. Instance of type capital A, and B is a null pointer. But when I do the assignment of A to B, it transfers the ownership, and afterwards A is now invalid and B has the valid pointer. So it doesn't allow you to share the data at all. It's a way to track ownership of allocated memory and give it to other people, other parts of the system. And so if we utilize this to apply it to publishing in ROS 2, you can see in this example we're creating a unique pointer rather than a shared pointer, as we did before. I assign testing to it and I call publish on it, and what's happening in that publish line is I'm giving the ownership of that message to the middleware, and I no longer have access to it. So previously the line where I added testing to the data, that would actually be a seg fault because you're accessing a null pointer there, and there's no longer this implicit contract, it's an explicit thing. I forgot to mention, this is not always the best solution. Sometimes you actually want to have this implicit contract where you give a shared pointer and then later you're going to reuse it or something like that. That takes more overall system design, but it's something you may want to do. So it's something, it's not a silver bullet is what I'm saying. We might want to preserve the feature that's in ROS 1, but I don't think it should be the default, I guess is what I'm saying. If we think about it from the subscribing side, first let's look at a typical example. So this is like a ROS 1 typical thing. You have a callback, you receive a shared pointer of a message, and if you want to modify that message, it actually comes in as const. And the reason it comes in as const is because the middleware may need to give that same shared pointer to other callbacks, and so it can't allow you to modify it in between. And so if you want to modify it, you need to make a copy of it first. And this is pretty common with something like a transfer function where you get, let's say, an image in, you want to mutate it and publish it out to another topic as sort of like part of a pipeline. And so we can't gain a lot of benefit by using a unique pointer here, but it can simplify our code a little bit because when we ask the middleware for a unique pointer, then the middleware has to make the copy for us. So it's like a little less code. And there's one very special case where this can be, it can avoid copies altogether, and that's the case where you have one publisher and one subscriber, so it's a one-to-one relationship on the topic. It's not something you can depend on, but in that case, the middleware will do the most efficient thing possible. So I'm going to run a demo really quick. Okay, Dirk's going to do it. So this is a really simple toy problem that I set up. So we're going to run it for like a second or two, and then I'll get Dirk to stop it. So you can go ahead and stop it. Is there a laser pointer? No. Okay. So it's a little bit hard to read with this resolution, but if you look, the first thing that happens is we say, I'm going to publish the first value of 42 with a pointer address of that hex value, and then it sleeps for a second, and then it increments the value and publishes it again. So now we have a 43, and it's the same pointer. And the point is that we receive a message, we wait a second, we increment, we publish it again, and it has the same address all the way through. And to make sense of that, we'll look at the code a little bit. I've tried to slim this code down a little bit so it's easier to parse, but I'll go through it really quickly. So we have basically a struct or a class here that's inheriting from the node class in the C++ client library for ROS2. So it's overriding the built-in function in some places. So we have like a constructor that takes a name, an input topic, and an output topic. And then this code I have here is the callback for when it receives a message on the input topic. So you can see it receives a unique pointer. It prints out the value and the address of that pointer. It waits for a second. It increments the value of the data, publishes what that value and pointer is, and publishes it along to the output topic. And where this gets interesting is looking at the custom main file I've written for this example. So what's happening is I'm creating two instances of this class with different input and output topics such that they form a cycle. So if one of them receives on topic 1 and outputs on topic 2, and one of them receives on topic 2 and outputs on topic 1, and they have different names. And then so I create one of each of those, and then I start the cycle off by calling the publish function on the publisher inside of the first class with an initial value and message, and then I just add them to an executor and call spin. This is how you would do multiple nodes. This is equivalent of ROS spin for multiple nodes, essentially. So the result of that is that these things, I kick it off with that first publish, and it goes round and round in a circle, always reusing the same message and never allocating. And so this is kind of just it's not really something I expect people to do in practice, but it sort of demonstrates the middleware as being as efficient as possible in that case. And so in that case, it's kind of interesting. So what can we say about using the unique pointers in this way? So it can help us make efficient pipelines. In the case that it's one-to-one, again, it's not something you can rely on because if somebody adds introspection within the same process, you might not have that relationship anymore, but it will be performant when you have that scenario. It's not always the preferred signature. Sometimes you want to use shared pointers, and we should support that too, but maybe it shouldn't be the default behavior. Perhaps the semantic break from ROS1 should be that if you publish a shared pointer by default, it makes a copy rather than having this implicit agreement. And if you want to do that implicit agreement where you give it a shared pointer and it doesn't copy it, you need to tell it that's what you want to do. It needs to be explicit. And this really matters in situations where you want to have really high performance publish subscribe, but you want to preserve the behavior between inter-process and inter-process, and you want to minimize copying of data. And just quickly about the consistency between the two. I explained how in intra-process in ROS1, when you call publish, that goes through to the callbacks that are connected to that within the same process. That's starkly different from what happens in inter-process, where you call publish, it's always non-blocking. And I think that should be preserved, and we work around that with the different way of implementing the intra-process, and if you want more details about that, we can talk about it later. And so next thing we want to do is make the intra-process implementation a little more intelligent so that it can be as efficient as possible in every scenario, including when you're giving it shared pointers instead of unique pointers and things like that. And really take a hard look at the implementation we have for the inter-process and make sure it works for cases like real time and static allocation and stuff like that. And we still have some work to do and some other features like type masquerading, which is like when you want to publish a custom type like an OpenCV mat or a PCL point cloud rather than our generated code types. And we need to work on running multiple nodes in a single process, adding infrastructure to make that easy to do and convenient. And then finally, I'm going to pass off to my colleague, Esteve.
Hi. Sorry for the voice. I'm not 100% today, but that's fine. I'm Esteve, and I happen to work at OSRF as well, on ROS2 as well. So I'm gonna talk about quality of service in ROS2. So I'm going to give you a bit of a context about what we mean by quality of service and what's the status of quality of service in ROS1. So in the networking spectrum, we got on one end UDP, which is connectionless, and that means that there's no acknowledgement whether a package has arrived to the other end or not. On the other end of the spectrum, we got TCP, which, on the contrary, it gives you acknowledgement whether a packet has arrived, it'll retry, and so on. But DDS, by using DDS, we can have access to more granularity between the two, because DDS is implemented on top of UDP, and in order to have this granularity here, DDS implements reliability on top of UDP. We'll see how this is important later, but we'll see. Okay, so what's the status of quality of service in ROS1? We got quite a few options in ROS1 which were added as an afterthought, like UDP ROS, which is great for best effort, TCP ROS, which is the standard protocol in ROS1, which makes polysubscribe reliable. Well, the problem with this is that UDP ROS doesn't talk to TCP ROS, so it's all or nothing. You make your network, all of your subscribers, best effort or reliable. There's no middle ground. Queuing with ROS2, we also got kind of the concept of queuing. But we can also store all the messages that the data reader receives or data writer writes. And latching more or less translates to durability in ROS2. Latching is a feature that it's a bit little known, which, well, it allows you to implement store and forward semantics. Besides this, there's more QoS capabilities in ROS2 thanks to DDS, but this is more or less like a mapping of, not one-to-one mapping between ROS1 and ROS2, but it gets the point. So there's a thing we've said for the last year and a half, that by not implementing our own communication protocol and by delegating all that stuff to DDS, we can focus on other things. Well, it's the same with QoS. We haven't implemented QoS ourselves. We just let it to the DDS vendor, the underlying DDS vendor, to handle all that stuff, which is great because, for example, we don't have to document it thoroughly. It's documented in your DDS vendor of choice. It's also part of the standard. So you get the same behavior, whatever vendor you're using. The other thing that I mentioned is that DDS is built on top of UDP. Why is it so important? Well, it's so important because you can also have multicast, which is not implemented either in UDP ROS and obviously not in TCP ROS because that wouldn't be possible. Why is it important? Because in a pub/sub framework like ROS, not making extra copies of the message to each and every subscriber, it's kind of a big deal. It makes your network less congested, and that's always a good thing, obviously. And all of this is motivated by our goal of reaching more users. The ROS1 was built with the PR2 in mind. Obviously, ROS1 has been ported to other robots, but always a bit of an afterthought. So with ROS2, we want to tap into all these robots, like drones. Drones use unreliable networks, so that's why it's so important to have quality of service. The Internet of Things requires efficient multicast and high latency links. You know, if you have a robot in space, for example, I don't know who would put ROS in a robot in space. Probably the same folks who say that there's water in Mars. I don't know. So you got a huge latency, as you can expect. So that's also important to have quality of service in that case to control the behavior of the network much better. So I'm going to show 2 demos. Actually, Dirk is going to show them. Yeah, so we're going to simulate that there's 25% of packet loss. We all know that localhost is the only reliable network, so we're going to simulate that. So as you can see, there's kind of a bit of latency. And this demo is what ROS1 would do with TCP ROS. All the images, all the frames are sent, are published, and all the frames are acknowledged. That means that you get all the frames, obviously, but at the expense of having a high latency. So we are going to show how, with using best effort, you know, well, there's some frames being dropped, but video becomes more fluid. And here's the cool thing: the window on the left, it's always been a reliable publisher. But the window on the right, it's a subscriber that's using best effort. That's something you cannot have in ROS1. You cannot have UDP ROS talk to TCP ROS, obviously, because they are different protocols. But in this case, both are using UDP with different quality of service settings. And why is this important? Well, if you have a sensor and you care more about having the readings quickly at the expense of losing some, that's what you would want to use. Okay. So how do you? Well, this is the second demo that we just saw. So how do you access QoS through the ROS2 API? Well, we came up with this, and when I say we came up, we more or less were inspired by the DDS spec, which is QoS profiles. QoS profiles. Okay, faster. Okay, sure thing. This is my last slides. Okay. So QoS profiles are a set of QoS policies that provide all these QoS settings. We have a set of predefined profiles that you may use off the shelf. We are still tweaking these values, the values for these profiles. We want to receive feedback from the community and more use cases, because obviously we cannot test this in all the use cases that you guys want to use ROS2. And obviously, because there are people who are already using DDS, we don't want to disrupt their deployment. So at all times you can still pass system default option, and you can use your own the tools that come with the DDS vendor to tweak the QoS settings, and we won't get in your way. That's it.
All right, now we get to the next demo. That's also the last. So we do have now some prototype for ROS2. It has a lot of new features, especially a superior communication protocol. But there's ROS1 with all the tools and all the existing functionalities. So how do we get that together? So imagine you have a ROS2 publisher which publishes images, and you have a ROS1 tool like RQT, which already subscribes to images, provides you UI and everything. How can you make them like talk to each other? And one approach we currently worked on is like a network bridge, which will like sit as a separate process, and it actually is a ROS1 node as well as a ROS2 node at the same time. And it looks at the ROS master and at the DDS discovery protocol to check what topics are available, and when it finds two matching topics which it can like exchange, it just signs up on one side and publishes on the other side. And in order to show you that that's not only like a slide, oh yeah, thanks. Thank you. So since we use ROS1, we have to start the ROS core as always. I start the bridge in the second one. Get a lot of windows here. First, I just show a ROS1 node, which is publishing the images. And RQT, as you might have used already, which should show us the images.
On the wrong screen.
Oh. So here. No.
Trust us. Okay.
Oh, that's big. Well, that's me. And sorry, I'm gonna like stop the other one. And now instead of using a ROS1 node, I will start in the last window node, which is a ROS2 node, publishing images. And you're gonna trust us, the screen is again here. No, seriously. I'll show it briefly. Let's see if I can dock it. Oh my God. Well, that's good enough. I wanted to show also that you can basically also have a back topic, so you can send a message back, and that gets transferred from the ROS1 node back to the ROS2 node, so it's bidirectional if you want to. I'll skip that for now. I'll keep it running. Thanks. All right, so the technical background for that is currently the bridge is implemented in C++, simply because we don't have any Python code yet. How it works, it uses the ROS MSG API. It's a Python package in ROS1 to find all messages. It's kind of ugly. It crawls your file system, finds all .msg files, takes some time. In ROS2, we have worked on that to improve the lookup. So you basically look up at an index which gets generated at compile time. So no crawling anymore. One of the benefits, one of the other benefits from ROS2 over ROS1, which goes beyond like just using DDS. Then the bridge looks at all the ROS1 types and the ROS2 types, and based on some automatic rules, for example, same name, it considers some of them to be like pairs. You can also customize that if you have like a specific mapping which is not covered by the automatic rule. And it generates code to transform ROS1 messages into ROS2 and vice versa. And afterwards you build an executable which basically is compiled against ROS-CVP in ROS1, the C++ library, or RCL-CVP, which is the ROS2 equivalent. One challenge for that, since this is all C++, you need to include all your headers, and all these headers must be non-colliding. So if we've been careful until now to like have different namespaces for new classes in order to be able to build a program like this. Then a short sentence on the roadmap. I don't know how many have noticed, but we announced last month, the Alpha 1 release, which was the first time we did like a release of ROS2, which was one big archive with all the demos and tutorials. You can go to the wiki page and just try them out. We have also put together a roadmap where we describe what upcoming features we will work on next, and also what other features we have planned and in which order we might want to tackle them. And for example, the next work items for the Alpha 2 is we focus on component lifecycle, that you can also introspect that life cycle through a service, for example, and you can orchestrate it so you can change states remotely, reuse things we have from ROS1 like class load and plugin lib, and also make the launch system use that. So actually be able to have a launch file which starts multiple nodes, waits until they are all initialized and every network connection has been established, and then start them, which makes it way more predictable. And other topics are continuing to work on some technical challenges in C++, which we're currently facing, and then also revisit the C API and try to make a first API Python implementation. Two other related presentations. You already saw the first one this morning from Morgan about embedded systems for ROS2, and after this one you will see the talk about real-time from Jackie. If you want to get the slides, you can just scan the QR code, and I'm happy to take some questions, or we are all. Thanks. The question is, since the API is partially different, is there a way to migrate existing code automatically through some tool which does all that? The answer for that is we don't know yet, because the API is not finished yet. We have a first prototype version, but there's no reason to believe that that's the final result. We can always tweak them based on feedback, because the more we develop on top, the more we will learn from it. The other part is the migration would be one step, but we try to make it probably on top of the API we imagine. We probably put an API which is very similar to the ROS1 API to let you keep most of your code as a backward compatibility layer. But that needs to be figured out, how much can we abstract and how much changes is necessary. And I think that's currently on the list for the Alpha 3. So after that's packaged, the next iteration. And then we have to look in, can we cover those changes by a tool? I mean, we've seen other projects doing this, like Qt 3.4 was a nice tool to convert existing Qt 3 code. So I think something like that is definitely possible. Do we cover 100%? We'll see.
I would just add to that the static conversion may be possible, but we have to be really careful. And maybe this is parts where Qt3 didn't do for parts to Qt4, because there might be semantic differences. Like when I talked about the changes in intra-process publishing, the API could certainly be adapted, but the behavior may not be the same. And so we may have the tool say flag it and say you need to look at this yourself, and here's a document that tells you why you need to look at it. But yeah.
Other questions? Over there.
I believe the question was, will ROS2 support inter-process shared memory, as in the operating system shared memory? That's actually handled by the middleware. So for example, OpenSplice and Connext both, and I think FastRTPS as well, they all have a shared memory shortcut, but that's below us. So basically we're going to do shortcuts in the intra-process step, and the middleware would be up to the middleware to do shared memory. But they do implement it, most of them.
Because another advantage, which William described with shortcutting it just by passing a pointer, is you don't need to do serialization. If you use shared memory, you still have the serialization step.
More questions? Ian.
You mentioned that you'll have different APIs like Python and C for ROS. So would this make sense to have everything just auto-generate from C++, plus dependability, or is that not feasible?
So the question was, we will have different APIs besides C++, like C and Python, if we can generate them and don't have to write them manually. So I think there's one very different thing in ROS2 than in ROS1. In ROS1, it was every language was built completely native. So Python was a completely Python implementation. Java, we heard before, completely Java implementation. For ROS2, I think the goal is to allow us to not do that again. So most of the implementation currently is C++, but we will probably push a few of that in C, or at least rip it in C API, and then try to use bindings for Python. But I don't think it will all be generated. I think there's always some part which you want to make more Pythonic, because you want to have an almost native experience. So maybe something like the threading, you will use something in Python and not reuse what you have implemented in C or C++. But of course the goal is to reuse as much code as possible, just to keep our effort low.
Middle. There you go. I see you now.
One of the slides with the code examples, there was very shortly, very briefly on screen, a node which extended a superclass. And I remember from the ROS1 documentation, it explicitly said we don't want to take it for your name, we don't have a subclass or anything from us. I was wondering why we chose to do it differently.
Yeah, so the question was, in one of the slides, we had an example where you inherited from a node class as opposed to instantiating a node and writing your own main function and using it that way. And why are we changing that? So basically, we did have this mantra in ROS1, we won't wrap your main. And I think that's important, and you can still do that in ROS1. You can still do it like you did in ROS. We had another example in the slides where we had a listener program which had its own main, and we had a ROS2 version of that that was very similar. But the point is that we would like to propose encouraging people to do it as inheritance from a class instead. The benefit being if you do that, then you get to defer execution of your node, and therefore you get more reusability, because then you can later decide if you want to have your own main or share a main with other people. There will always be the case where you need to have your own main function for whatever reason, handling your own threading and stuff, and we want to enable that. But for the default case, you can get a lot of benefit, or we can provide a lot of more benefit if we have them in more of a component style, where you're like, modifying a subclass. Yeah, currently you have to choose that at programming time, because nodelets are the same way. If you want to make a nodelet, you inherit from a class, and that's because execution is deferred from you to the system.
And I'll just add that we're adding that feature, the ability to have this component model that you can inherit from if you want, was based on feedback from users, especially users in industry. So don't wrap your main gives you the most flexibility possible, which is great, except when you don't want that flexibility, where what you want is a very clear way to describe a component of computation and have everybody be able to follow that model and then compose the system correctly at runtime. So this is something that people have asked for, but you absolutely don't have to use it. You can write your own main function if you don't like it. More questions? Bill?
Have you guys given much thought to sort of what ROS topic list is going to look like in terms of the namespace, since it's classless, I guess? There's no ROS core.
Yeah, so the question was, what is the behavior or the interface of ROS topic list, for example, since there's no master anymore? This is actually a really great question. With DDS, because it's all distributed discovery, you actually have to wait a little bit of time before you get to hear from everyone. And that's sort of an experience breaker for something like ROS topic list, where you want an immediate response. And so we're looking at ways to fix that. I think probably what we'll have is we'll probably still have something like the ROS core command. The difference will be that it won't be required to run nodes and stuff like that, but if you have it running, then ROS topic list can be faster and it can act as a service. That's something we're actually still looking at. You have a follow-up.
Yeah, the follow-up question is the parameter server.
Okay, so the follow-up question was, what about parameters? So we just wrote a white paper or an article about parameters and how we'd like to see them in ROS2. Just quickly, the gist is that we have this idea of parameters in ROS1, which are static, and we have dynamic reconfigure. The main conceptual difference is that in dynamic reconfigure, the parameters are owned by the node and tied to the lifetime of the node. We'd like to see that as the default in ROS1. There are some use cases where having a global parameter server or having parameters exist beyond the life cycle of a process are important, and we're looking at ways to do that without having to have a parameter server, but that could be emulated with this design that I described. Basically, you run a node that is the global parameter server, which just accepts all changes, and then you can basically emulate the global parameter. Esteve would like to add.
Yeah, we have an implementation of that white paper, but we haven't included it for the pre-alpha because there are still some things that we have to iron out. But you may check it out from the ROS2 repo.
All right, one more question. Moritz.
So what's the plan regarding all the tool landscape? I mean, starting from the low-level tools like ROS topic list, so going up to mid-level tools like ROS, top-level tools like moving, navigation stack, and so on. I mean, there's a huge code base that has to be migrated, and if you chose to be not API change the semantics, the execution semantics in the background, and a huge code base has to be migrated before ROS2 will be even close to being as usable as ROS1.
Yeah, so the question is a general question about migration. Since we are breaking the API and even changing semantics of the API, there will be manual labor involved in the conversion of things. And the question was, how do we see that going forward with starting with low-level tools all the way up to things like RViz and MoveIt? Is that a fair summary? At least the way I see it is that ROS1 will continue to be the mainstay of most people, and ROS2 will exist on the periphery in special cases where it excels, and we'll make use of the bridge. That's why we think the bridge is so important. It's so important to have an efficient bridge, is because tools like RViz and ROSBag in the early days will probably stay in ROS1. We'll slowly start moving things over to ROS2, but there will be more than just converting the API. It'll be an opportunity to reevaluate how those tools are designed and take advantage of advantages in ROS2 to make them better. For example, RViz could be made to use, have configurations for things like unreliable, a lot more quality of service settings, so you can get a better use out of the tool. Things like, the navigation stack might be able to use the multi-nodes in a single process as a better design pattern. Things like that. So I think it'll be probably a pretty slow process, but we want to make it a heterogeneous system process where you can do it through attrition and you can really take the time to take advantage of the improvements in ROS2 as you go. At least that's the way I see it. Maybe other people on the team.
I'll just add that one other thing that we haven't started work on yet, but that we've talked a bit about, is something we're colloquially referring to as a library shim. So this is something you could imagine in any language, starting with C++, but you could do the same thing in Python. You could take your existing, it would present a ROS1 API, but under the hood would call into the ROS2 libraries. And William will remind me every time I talk about this that there would be caveats on what exactly the behavior of the system would be, but the idea is that we can give you qualitatively the same behavior using the existing API. And that's a thing that we haven't been able to estimate the difficulty or completeness of that project yet, but I think that is something that we will pick up and use. And so there are going to be different migration paths for different use cases where we're not, a gang of supervillains out to give you a really bad day. We want to make this as useful as possible and make it as easy as possible to migrate. So we're totally aware of those issues, and we want to keep the feedback coming on how we can make it as easy as possible. And with that, we're done. So let's thank our speakers.